Hi everyone, this is our assignment 3 that introduces the baseline scheduler. This is the link to this video.
Now, I would like to talk about the baseline CPP feature. Round robin algorithm is implemented in this CPP. Uh, now I would like to talk about the advantage and disadvantage of round robin. The advantage is fairness as no priority scheduling is involved. I would like to talk about disadvantage. The disadvantage is high priority customer must wait longer compared to the low priority customer. Now, I would like to talk about features of round robin. The first one is it's easy to implement compared to the other algorithms, such as first in, first out, and shorter job first. Round robin algorithm is primitive. And now, lastly, I would like to talk about time slice. These features give the processors equal opportunity to use the CPU.
Here is a definition of the DQ and vector. In here, the most important is waiting queue. It lets all new process is put in the ready queue and wait until it's selected for execution. The DQ is different between the array and the vector because you are able to add and remove items from the both front and both back of the queue, but array and vector is difficult to remove the front or add in the front. That's why I use DQ as I choose to use waiting queue. And this is the algorithm of the baseline, which is a round robin. At the first, we define the variable called ODowns. It's whether the tracking program has been complete. Only when all the customer is not in the waiting queue and no new arrival events and the current use machine is empty, we set all down to true. Else, if the all down is false, that means the process is still working. We continue at the current time. As long as arrival time is equal to the time the customer wants to end the game, and the square bracket 0 means that we only look the first element from the vector once, and we continue as the customer from arrival event queue into waiting queue. Because the customer already into waiting queue, so we don't need the customer still in the front of arrival event. That's why we use push back and push front here. And for if statement of current ID, 0 means the machine is not empty. We check if the customer process had time remain. The means that process is not over yet. It will push customer back to the queue. That's actually normal round robin work. Round robin usually employs a scheduled share, giving each job a time slot and interrupt the job if it has not complete by then. The job will resume the next time a time slot is assigned to the process. If the process changes its state to waiting within its attribute time period, the scheduler chooses the first process in the ready queue to do that.
Here, the program is checking if the machine is empty or not. If else statement is implemented when current ID is -1, it means there is nobody. And also, it is checking if any customer is waiting at the queue or not. This checking because if there is a customer waiting at the queue, the program cannot exit. And also, queue.pop front is used because the customer waiting at the front of the queue should get the chance to use the machine first. That's why queue.pop is used. Moreover, it is also checking if there is a timeout or not. If yes, the customer will be put off the machine. Finally, when there is no customer waiting or playing, the program will exit.
Overall, the baseline scheduler is effective at managing customers through its use of the round robin algorithm. It is faster than other algorithms such as first in, first out, and shortest job first. A couple of things that could be improved in this baseline scheduler would be to address customer priority levels, which it doesn't currently do, and while starvation isn't an issue, some considerations need to be made for the time quantum length, as it has the potential for this scheduler to perform effectively the same way as a first in, first out algorithm. Thank you for your time.